out with T, F, A, oh, start all over. I messed up already.
Just
okay.
keep going.
Your girlfriend's
PP.
PP is an A, because she has good P.
Right.
Okay, so that's how you have to, I made that to remember, because all of these things kind of get confusing in my brain if I don't do that.
Okay.
So it starts out with glucose, which is 6 carbons, and then it enters the, oh, by the way, this whole process is called cellular respiration. So glucose enters the plasma membrane through facilitated diffusion because it's big and polar, and so since it's using facilitated diffusion, it uses up energy. So 2 ADP goes in, and then 2 ATP comes out. So then you have your F, fructose diphosphate, which is also still 6 carbons. And then fructose diphosphate automatically splits into 2 P-gals. So there's your P-gals, which is 3 carbons. And then, I'm taking up too much room on this. Whatever. And then it goes here. It's going to end up turning to pyruvic acid, both times, which is 3 carbons. But then here it goes NAD plus to NADH, and then 2 ADP, because you're getting, or 2, yeah. Shoot, I messed this up. It's okay because I noticed it.
Good. Yeah.
It takes up energy to enter through the plasma membrane. So 2 ATP goes to ADP. It loses a phosphate group. And so then your 2 ADPs coming back here, giving you back your energy. And then it's doing the same thing on both P-gals.
Okay.
2 ADP to 2 ATP. And this is where it starts to get kind of funky, because normally I would show it like this, but since it's a whiteboard, I'm just going to kind of go like this.
All right.
There's 2 types of fermentation.
Gotcha.
It's either one or the other, it's not both, but I have to memorize them both, so I have them both on one drawing. One is called, I'm just going to do this one, the shorter one. One is called, which one's alcoholic fermentation, and the other one is lactic acid fermentation. Okay, so here the alcoholic fermentation starts off losing a CO2 group, and so then it turns into 2 carbons because it lost carbon, because it was at this 3 carbon, lost carbon, turns into 2 carbons, and then you have the NAD plus to NADH again, because that just happens all over the place, and then you get the ethanol, and this is the way to write out ethanol. And then ethanol is also 2 carbons, as you can see. 1 carbon, 2 carbon. And then the other one here is where you just have NAD plus, I messed up again. It's
right.
NADH to NAD plus. NADH, because, see, this is why it's confusing, because sometimes they switch. When it's fermentation, it's NADH to NAD plus. And this just turns into lactate, which is also 2 carbons. Then, up here, this is gonna go on this way, but
Gotcha.
I'm gonna just erase it.
Alright.
Okay. Oh, all this stage right here is the glycolysis.
That is correct.
Okay. I've erased my GFPPA. Okay. Then pyruvic acid, 3 carbons. So then the pyruvic acid enters the mitochondria, and then CO2 leaves, and then a CoA, which means coenzyme A, enters, and then also with that, need a longer arrow, NAD plus goes to NADH, and this makes my A acetyl CoA. Bam, done with that. So, and this acetyl CoA is, since this was 3 carbon, it lost a carbon here when the carbon dioxide left. So now this is 2 carbons. And then enters, this is called the prep step. And then, prep step. And then it enters the Krebs cycle. So during the Krebs cycle.
I've heard of that. Krebs cycle.
Really?
Yeah.
During the Krebs cycle is, so it's actually kind of dumb because it just loses the CoA again. Like it goes CoA in and then CoA out. Like that's the only time you ever. But, so then, it joins with the 4 carbon. He said it doesn't really matter what the name is, all we have to know is how many carbons it is. So this 2 carbon acetyl CoA joins with 4 carbon, loses the CoA, turns into 6 carbon. And then you have to know the cycle. It goes 6C, 6C, 5C, 4C, 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 4C. So there's 4 4s, 1 5, and 2 6s.
Okay.
This one is called, they all have names, but he wants us to remember these 2. This one's called citrate, and this one's one I have troubles memorizing, but I think I got it. It's oxaloacetate. Oxaloacetate. And so, from this step to this step, nothing happens, but from this step, as you can see, it loses a carbon. So that means that CO2 exits. And whenever CO2 exits, an NAD plus is converted to NADH. It's happening here. It's losing a carbon, so carbon dioxide leaves. NAD plus goes to NADH. And then at this step, it's, remember it because you just kicked her.
No, I just wanted to see if she's still alive.
Okay. At this step, it needs more energy because it's been doing this cycle for so long. That's how I remember it. So it turns ADP into ATP because it needs more energy. And then it goes FAD to FADH2, and then on this step it goes NAD plus to NADH again. And this is all called the Krebs cycle. Okay, now, I'm very sick, so time to leave the room. Oh gee, I'm running out of room. Okay, this is going to be kind of smaller than normal, but it's okay. So here is the ETC, electron transport chain. I don't want to write it all out.
Okay.
We've got complex 1, complex 2, complex 3, complex 4. This is going to be really squished. And then this is the A. I'm just going to erase it and redo it because I need more room for this.
That's fine.
Oh, this isn't good. But it's fine. It's fine. I know how to do it. So.
Good.
still got your cycle going on over here. Your cycle was happening. So this is the phospholipid bilayer, and this has a high concentration of hydrogens, and it's called the intermembrane space. And this has a low concentration of hydrogen in the matrix. And so, like I said before, complex 1, complex 3, complex 2 is here, complex 4, this is ATP synthase. And then here you have, I didn't really leave enough room, ubiquinone. And then here is cytochrome C. Okay, so from here, normally I do...
How many more minutes is this going to
How
be? You
long
said
has
5.
it been? How long has
It's
it been?
11 minutes so far.
Are you serious?
Keep going.
Wow, okay. It's almost, this is the ending part.
Good.
Okay, so...
It's really impressive.
Over here, the FAD plus was converted to FADH, which is going to be used to go here. FADH goes back to FADH2. I always mess up that. FADH2 goes back to FAD. And then here it was NAD plus to NADH. And that NADH goes it's just taking so long.
Right.
The NADH goes to NAD plus again. And so it loses a hydrogen here. So the hydrogen goes up. Hydrogen. And then when it loses 2 hydrogens here, because it's H2, so one goes up here, H plus, and the other one goes up here, H plus. And the whole process of this is to transport high energy electrons. This thing right here has 2 electrons in it, and this one 4 electrons. And so this is where my teacher messed me up on the last quiz, but you have electrons entering. It goes to this is like the process that the electrons take. It goes
Gotcha.
complex 1 to the ubiquinone, to complex 3, to site C, to complex 4. So that's how the high energy goes. And then here you have 2H plus and also 1/2 O2, which is kind of weird to say, but they just say that because in reality it'd be happening like twice at one time. It'd be 4H plus and 1 O2, but like I just have to memorize it like this.
Gotcha.
And that turns into H2O. And we're almost done with all of the, since this has a high concentration of H plus, one of the H plus enters and leaves. And then what also leaves through here, is the last part, tons of ATP, 34 to be specific. And that's what the whole point was, to get your energy. So that was solar respiration.
By Annie Green.
Thank you for watching and listening.
5. That was awesome.